Now let's put this into a problem. On page 17, heating a plate. When a circular plate of metal is heated in an oven, its radius increases at this rate, 0.01 centimeters per second. So it's not growing a lot. Oh, wait, but 0.01 centimeters every second, because heat makes things expand, right? Things are going to expand when they heat. At what rate is the plate's area increasing when the radius is 50 centimeters? So here's the deal. We got to extract some info real fast. We're going to take every piece of info and we're going to write out what the heck it was. It says its radius increases at this rate. So would I be able to say my radius equals, does R equal 0.01 or does our dr dt equal 0.01, right? The rate of the radius. So we're going to write dr dt is 0.01. We don't need units or anything because we're just extracting some info. Then it says, at what rate is the area increasing? So this is what they're looking for. Are they looking for area or dAdt? dAdt, because they're asking for a rate. So I'm going to say, all right, dAdt is, I don't know. I don't know what that is. That's what we're looking for. And it says, when the radius is 50. Is that R equals 50 or dr dt equals 50, do you think? Radius is 50. Very good. So I'm going to say radius is 50. So that's just some info that I like to take out from the problem. And then we got to go say, all right, if they want dAdt, they want the derivative of area, could I start with area and then go take its derivative? Area of a circle is what we're looking for. What's the area of a circle formula? Pi r squared. Very good. And if they're looking for dAdt, to get dAdt, that just means derivative. Let's go take the derivative of this. What is the derivative of area? dAdt. Okay, so we're taking the derivative of this. We're taking the derivative of this. The derivative of area is dAdt. The derivative of pi r squared would be
2 pi r.
2 pi r
times dr dt.
Very good. Times the derivative of the radius, dr dt. So just a reminder, any variable, we're going to need a derivative of it. So the only variables in here were a and r. So this is chain rule. We took the derivative of the outer, we left the inner, times the derivative of the inner. Now it's just plug and chug, guys. Do we know what dAdt is? No, that's what our unknown is. So I'm just going to say, I don't know what that is. dAdt is 2 pi. Do we know what r is? 50. I'm going to go plug in that 50 from right here. And then do we know what dr dt is?
0.01.
0.01, and we had that from over here.
And we can easily figure out that it's pi.
How did you know that?
Because 2 times 50 is 100.
Whoops.
And 100 times 0.01 is 1.
100 times 100th is 1, right? Very good, sir. So the rate of change of my cute little circle is pi. What do you think my units would be? We just found a rate, dAdt. We found a rate of it. So I'm going to use whatever rate they had before, centimeters per second.
Well, wouldn't it be centimeters squared per second since it's area?
Oh, you're so right. Bless you. You're so right. This is the rate that the area is changing. Area is always square units. I mean, Coop. So good. Okay, let's keep it up, peeps. Now this one is a little less real worldy. This one just says, hey, we've got this equation. W equals x squared y. And then they're going to give us some info. Let's extract it. X is decreasing at a rate of 1. Am I going to say x equals -1 or dx dt equals -1?
dx dt.
Yeah, whenever we see the word rate, people, we're going to do a derivative. So I'm going to say, all right, dx dt. And I'm going to say -1 because they said decreasing. And then it says y is increasing at a rate of 4. Bless you. As soon as I hear rate, I'm going to do dt. So I'm going to say dy dt is +1 since it's, +4, my bad, since it's increasing. What rate is w changing? What rate is w changing? Do we want w or do we want dw dt? Very good. We want dw dt. We don't know what that is. They said what rate? We're like, okay, I don't know. With respect to time, when x is 6, I'm just going to write that out, and y is 20. I'm just going to write out all that stuff that they gave me. If we started with this and they want dw dt, to get dw dt from this, I got to take a derivative. What's the annoying part of this thing? When we take a derivative, which one of those rules do we need? We got to use product rule. Oh, man. So I'm going to just write it down here so that I can write that product rule underneath it. This is one function. This is another function. Let's go take its derivative. dw dt. What would f prime be? Careful. Very good, Bob. 2x dx dt. That is the derivative of the first function. Leave the second function. I'm going to say y. There's my fig. F prime times g plus g prime. Derivative of y with respect to time.
That's just dy dt.
That is just dy dt times f.
X squared.
Boom. Guys, now, that was the hardest part. Now it is just plug and chug. We don't know what dw dt is because that's what they're asking for. So I'm going to say, all right, that's where we're at. We're at dw dt is, I don't know. Then I'm going to say 2 times my x. What was my x? 6 times my dx dt. Did they tell us what that was?
-1.
Yes. Times my y. Did they tell us what that is?
20.
20. Sheesh. Plus dy dt, they told us is 4.
Yep.
And my x was 6, so we got to square it? Oh, my lantern. No calculator. Look, it's so sad. No calculator. We got this, though. We got this. I would do 20 times 6. Let's start big. What's 6 times 2 is 12. Add that 0. 120. And then I'd have a negative 120. Double it. Negative 120 doubled. Negative 240. Very good. Plus. Whoo! 6 squared is 36. We got to times that by 4. I feel like, oh my gosh, I really wouldn't do that.
Well, 72.
Exactly. That's a great way to do it. You're like, I know 36 times 2 is 72, and double that would get me 144. But we could also do it longhand if you're like, whoa, haven't done this in a while. 6 times 4 is 24. And then we got 4 times 3 is 12, plus those 2 is 14. So negative 240 plus 144. C, negative 96. Okay. All right, let's see. It says the length of a rectangle. We got a rectangle. I'm a visual person. I'm going to go show it. The length of a rectangle, and we got length and width. The length is increasing by 3 centimeters per second. Length increasing by 3 centimeters per second. Do you think my length equals 3, like L is 3, or is DL dt 3? DL dt is going to be 3. They didn't say the word rate, but as soon as they're giving us centimeters per second, that is a rate. So I'm going to write myself a little note. That length is increasing, DL dt, at 3 centimeters per second. The width remains a constant 5 centimeters. W or dw dt? Yeah, just my width is 5. How fast is the area of the rectangle changing? How fast is the area of the rectangle changing? They want dA dt, right? Okay. So if you didn't think how Dean was, a good call. So when it says how fast is the area changing, they want the rate of the area. You guys, we got to start with area of a rectangle. Area of a rectangle is always length times width, right? Yeah. And what can we put in right off the bat? Do I know what my width is?
5.
Yeah. So my original equation is area equals 5L, right? Or my area is L times 5.
And that just means we can completely skip the product rule.
Right, because to Dean's point, the change of the W, dw dt would have been 0 because what my width isn't changing. This is another way to bypass that. Good call. dA dt, the derivative of area, in this case, what's the derivative of 5x? 5, so what's the derivative of 5L? 5 times the derivative of L? dL dt. Did they give us what dL dt was?
Yeah, 3.
Yeah.
Oh, it's 15 centimeters squared per second.
Exactly. So we got 15. It says how fast is the area changing? Square centimeters per second. Very good. And how do we know that? Right there. Great job. Okay. Does anyone ever like watching like hourglasses or anything? I don't know. They're kind of soothing to me. So I say that because sand is piled in a right circular cone. And that just means a right circular cone means just that it's completely vertical, that it's not skew like this, like, woo, we got my cone going oblong, if you will. That's not right. Right just means it goes, that vertex is right in the middle. What's the matter?
Oh, wait, no.
Okay. Sand is piled into a circular cone. At 8 cubic feet per minute. What unit do you think it's talking about if it's talking cubic? Area or volume? Volume, right? The volume of this sand pile is changing at this rate. Because again, when they give you cubic feet per minute, that's a rate. So I'm going to say dV dt equals 3 here. 8. Okay. The radius is equal to the height. Okay. R equals H. We'll just not note that for later.
And H equals 5.
How fast is the height changing? Do they want H or dH dt? How fast?
dH dt.
Yeah. When they ask how fast, that's asking for a rate. They're saying, what is dH dt? When the height is 5, right?
Yeah.
And if the height is 5, could we also say the radius is 5?
Yeah.
Okay. And they will let us know. Just so you know, AP will give you certain formulas. They will give you volume of a cone. They're not going to give you area of a circle or circumference of a circle. Area was that pi r squared. Circumference is, actually, get this, you'll know it. If the area of a circle is pi r squared and we struggle with the circumference, you just take the derivative. What's the derivative of area? 2 pi r, boom, that's circumference. That's kind of cool. And that's not just a coincidence, because check this out. Area, okay, as we break this down, I'm going to show you, that is not a coincidence at all. Actually, we already did it. The volume of a volume of a sphere is 4/3 pi r cubed. And we already said the derivative of that is going to be 4 pi r squared, which is surface area. Okay, whoa. So anyway, I say all that because they're going to give you this formula. There's that formula. We need the derivative of it because they want dH dt. Gross.
Since we know R is 5, we could turn it into 25, right?
Okay, question. The only thing that we can put in this before we take a derivative, Coop, is a constant. Is anything constant? It says, how fast is the height of the cone changing when the height is 5? But when we're watching a thing of sand being, a pile of sand growing, isn't that height constantly changing? Yeah. As more sand, so that's not a constant. Like on the last one, it was like the radius is 5 or something like that, and it wasn't changing. All of these are variables, aren't they? Everything's changing. So you guys, we got to go take this derivative. We got to take this derivative. So the derivative volume, 1/3 pi is just, those are just constants. So I'd go put those with my r squared. And let's go do product rule, knowing this whole portion here, I'll highlight it, is all the first function, 1/3 pi r squared. That's just like saying 8r squared. Okay, so let's go find f prime. Oh, before I do that, because this is miserable. Okay, do you agree this is Ms.? We got a lot going on. Okay, to your point, Coop, if R is H, could I replace this H with R? This R with H, my bad. Yes. So you guys, could we say this original is 1/3 pi times H squared times H? And the reason I didn't put them all in terms of R, because I could have had an R cubed here, but since they want dH dt, I wanted to keep an H alive. So let's go simplify. My original is 1/3 pi H cubed. Oh my gosh, this is gonna make our lives so much easier. Now we only have one variable, and I don't have to do product rule. Did you guys just see what I did? Here's how I also knew that I should get rid of that R. I've got no R info up here, like dr dt.
There's no dr.
We can't have no info.
Yeah.
So again, I replace, since r is h, I put an h right there. H squared times h is going to get me an h cubed. Now let's go find the derivative of this guy. And it's much faster because we don't have product rule, because this is all just a constant. So what is 1/3 times 3?
Pi h squared.
Pi h squared times
dH dt.
dh dt.
Which means we're getting the area of it.
Huh. Yeah. I love that. Like pi r squared?
Yeah.
I got you. Now can we do some plug and chug now? Do we know what dv dt is?
Yeah, it's 8.
It's 8. Pi is going to stay pi. What do we know that h is at this moment?
5.
H is 5. I'm going to square that. Times dh dt. I don't know what dh dt is. That's what we're solving for, so I'm going to leave it as dh dt. And then if I wanted to get dh dt by itself, can I just take that 8 and divide by 25 pi?
Yeah.
And that's going to be my final answer. And if we're talking about at what rate is the height increasing or decreasing, what do you think those units would be? What rate is the height increasing or decreasing?
Feet per second.
Feet per
Minute.
minute, right? Just because that's what they gave us here. And since dHdt was a rate. All right, let's see how this one goes. Radius of a circle is increasing at a constant rate. R equals 0.2 or dr dt equals 0.2?
dr dt.
dr dt equals 0.2. The radius is increasing at that rate. What is the rate of increase of the area?
So we need the derivative of area.
We need dA dt. Very good. We don't know what that is.
We do know area is pi r squared.
We do know that.
But we don't have r.
Right?
But
What
we do have circumference.
the instant when the circumference is 20 pi. Circumference is 20 pi. So this is one where they make us know, we got to know that they're not going to tell us the formula for circumference.
Which is 2 pi r.
Circumference is 2 pi r. Whew. Okay. They want dA dt, the area, rate of change of area of a circle. So I'm going to be like, all right, I know area of a circle is pi r squared. They want dA dt, so I'm going to go find that derivative. The derivative, yeah. So he's saying, all right, the derivative of area is going to be 2 pi r, which is circumference, times the derivative of rate, which is dr dt.
Yeah.
You can totally think of it that way, Bob. Love it. Then we got to go plug some stuff in. We don't know what dA dt is. That's what we're solving for. So I'm just going to leave that as dA dt. I'm going to say 2 pi. Do we know what r is?
We can figure out.
We can figure it out.
It's 10.
Wait, do we know what dr dt is?
We don't. Well, we're solving.
Oh yeah, no, we've got dr dt right there. That's good. So I put that there. And then you're like, shoot, I would have two unknowns. I need an r. And I haven't used this piece of information yet. And if circumference is 20 pi and circumference
take
equals
20
2 pi r, 20 pi equals 2 pi r.
And then you divide by 20 by 2 pi. I had to get at 10.
Uh-huh. Yes, Miss Burke.
Do you even have to solve for r? Can't you just say that's 2 pi r?
Exactly. You're like, I just know my radius is going to be 10. Totally. Yep.
But do you even have to do that? It's like 2 pi r there, and you know circumference is 2 pi r.
Oh, I see what you're saying. You're like, couldn't I have just put in 20 pi right there?
Yeah.
Yes.
Okay.
And I think that's kind of what Bob was saying. Yep, Bob's saying, why are we taking this any further? I know 2 pi r is 20 pi right there. And I just got there in a much longer way, right? Because right here is 20 pi as well. Love it. 20 pi times 0.2 without a calculator. 20 pi times 0.2, you guys don't fret.
One would make it 2 pi, so it has to be 4 pi.
Right. So 2 times 2 is going to get me 4, but I got to move that decimal over. So 2 times 2 is going to get me 4. What are we doing with that decimal, though? Is it just going to be 4 pi? Yeah. Yep, my bad. Here's how I should have done that. I should have said 20 times that 0.2 is going to, or 20 times 2 is 40, and then move that decimal over the 1 to compensate for that. And that's just going to get me 4 pi.